Solving the MCQ of 2.3, measuring electric fields. Lines drawn to represent an electric field extend from, so basically away from a positive charge and toward a negative charge. So this is the correct answer. So away from a positive charge and toward a negative charge. Question number 2. An electric field is about 150 Newton per Coulomb downward. What's the direction of a force? On a positively charged, so basically because it is a positive charge, this means that F and E, the electric field, they must have the same direction. So also downward and downward. Question 3, the direction of the electric field is the direction of the force on a positive test charge. So the electric field at the location of the charge Q is represented by the following. So E equals to Newton per Coulomb, option A. The unit of the electric field, as we said, it is Newton per Coulomb because E equals to F over Q. Question 6, a positive charge Q equals to 3, 10 to the power of negative 7 is located in a field 27 Newton per Coulomb directed toward the south. What's the force? So E equals to F over Q, replacing everything by its value. F divided by 3, 10 to the power of negative 7. So it will give me an 8.1, 10 to the power of negative 6. We have a negative charge of 1.5, 10 to the power of negative 7 Coulomb. Experience a force F to the right. Now pay attention. It is to the right. The electric field. Now what's the magnitude and direction? Before talking about the magnitude, let us discuss the direction because it's a negative charge and the force is to the right. So basically the electric field should be in opposite direction. Because Q is negative, they must be in opposite directions. So it should be to the left, to the left. So let's consider only these two. Now by computing, so E equals to F over Q, which is 0.03 over 1.5, 10 to the power of negative 7. I'll have 2, 10 to the power of 6 to the left. The figure shows, question 8, point P at 6 meters from a point charge Q, which I see negative. What is the electric field at P? So as the charge is negative, so the electric field should be inward because it's a negative charge. On this line, so the electric field should be like so. So it is toward the charge. So let's consider this one and this one. Now let me find it by applying the other equation that joins. So E equals to KQ over R squared. Now the first one will not help me. Okay, so it is 9, 10 to the power of 9. The charge is 3, 10 to the power of 6, I take the absolute value divided by 6 squared, so it will be 750 Newton per coulombs, and as we agreed, it is toward the charge. Question number 9, what's the electric field this away from 0.25 meters away from a negative 6.5 microcoulombs? So E again is KQ over R squared, 9 10 to the power of 9 by 6.5 10 to the power of 6, negative 6, excuse me, 0.25 squared. So I'll have 9.3 10 to the power of 5. Please do not forget about the unit. Now, two charges, positive Q and negative Q, at equal distances from the origin is as shown below. What is the direction of the net electric field produced by the two charges? So let me start with the first one. It's a positive charge, so she will be doing an outward electric field. So along this line, this charge will be only doing outward. Especially here, it will do an outward field. Now the second one, along this line, it is a negative charge, so it will be doing an inward field. Especially along this line, it will do an inward field. So the resultant of these two will draw a resultant downward. So the net will be downward. Question 11. Which of the following represents the electric field line for a single positive charge? A single positive charge should be as A, inward, radial electric field lines that they are never meeting. Question number 12. Which of the following statements are true regarding the electric field? They originate on a positive charge and terminate on a negative charge. That's true. Field lines never cross each other. True. The direction of the electric field is tangent to the field line at any point. Also, that's true. So I'll take them all. So looking at this diagram in question number 13, I can see that both charges have inward electric field lines. I can see that they're both equal. None of them they have more electric field lines. So charge A is positive, no. B is positive, no. They're both positive, no. Eventually they're both negative because they both have inward field lines. About to be done. The electric field lines for a system of two charges is shown below. Which of the following could be correct about charges 1 and 2? Now, charge 1 has outward, so this is a positive charge, and 1 is inward. And it's very clear that charge number 2 has less electric field lines than charge number 1. So they all have those in common. This one, these ones, they are all in common. So let's not count them. So all of these are in common. This one has one extra, This one has so many. Okay, so I can see that the charge number 1 is much bigger and it is negative, almost double. So yes, let me go for the first. 1 is negative and 2 is positive, so I'll be discussing B and C. And looking at the number of the lines going into charge number 1, I can see that they are much bigger than 2. So yes, I'll go for B with the first is negative 32 and Q2 is positive 16. Now figure 15, it shows me, it's asking for the figure below shows the electric field in a region. Rank the magnitude of the electric fields at point A, B, and C. Now to discuss the relationship between the electric fields, I will have to look at the distance between the electric field lines. So the closer they are, the bigger is the magnitude of the electric field. So in region A, the distance is very tight, so very big electric field, very strong. Later comes B, and finally the distance at point C, which gives me that A is the largest, followed by B, and on C we have the weakest electric field. Thank you.